Over the next few slides, I want you to decide which characteristics these storage devices link to. Let's have a recap about primary and secondary storage. Remember that primary storage includes any memory internally inside the computer, whereas secondary storage is external. Most of these devices are portable. Primary storage is often known as main memory or internal memory. It's used to store computer programs whilst we're running them. The data on these is volatile. Well, in RAM it is, but ROM is actually not volatile. Remember, our term memory can also include virtual memory. And when we're talking about memory, we need to be thinking about internal primary storage. If we want to talk about storage in general, we'd use the term storage. Here's a summary of the pros and cons of each of the different types of storage. Take a second to go through these and have a look at the different positive and negatives, and make sure you've got these in your notes. In today's lesson, we're going to be looking at RAM and ROM. RAM is one of the main internal memory units inside our computer. We need RAM to store programs that are currently being used by the processor. We need to differentiate that when a program is not being used or run by the processor, it's saved in secondary storage and not in RAM. So RAM enables us to multitask. This means we can have several programs open at the same time and running. Think about listening to music while creating a Word document. Any programs that are needed by the CPU are copied from secondary storage into RAM when we need to process that data. This means it is much closer to the processor, and faster access times will mean that this data is much more efficient. It's going to store also instructions or modules from open programs that the CPU is going to need for processing. You now have a 2-minute challenge. I want you to use computers to research the following questions. Number 1, what is storage or memory? What's it measured in? Number 2, what are the high and low amounts of RAM in current computers? When upgrading RAM, can you just buy any new RAM? And the final question, what's the capacity of RAM determined by? Pause the video and try and answer the questions. So question number 1, we measure memory in bytes, usually in gigabytes or megabytes. Question 2, most computers nowadays are going to have either 4 or 8 gigabytes of RAM. It is possible to have more, but it's more likely that we're going to have 4 or 8 gigabytes. Question 3 we'll look at on the next slide. Please watch the video linked onto this PowerPoint. You might need to open up the PowerPoint version to watch it. You should come to the conclusion that you can't just buy any RAM and install it within any computer. Usually it needs to be able to be from the manufacturer of the motherboard or the computer, or with a certain style so that it can actually fit into the slots on your machine. As he mentioned, it's also important to think about the speeds that this RAM will be accessed at. Question 4. What is the capacity of RAM determined by? Pause the video and see if you can answer that question. Well, actually the answer to this question is the width of the address bus. Remember, the address bus carries the address of the next instructional data, which is going to be copied from RAM into the CPU. We can only have an address bus which can carry so many bytes of data in one go. And that is going to limit the size and amount of RAM that we have. Remember, every element of RAM is given an address. And so we need to be able to have an address bus which can carry the size of the address. Think about it like this. If we have an address bus width of 1, we could only have 2 memory locations in RAM, a 0 or a 1. If we had an address bus size of 2, we could have 4 options: 0, 0, 0, 1, 1, 0 or 1, 1. That means we can update our RAM, but if our computer isn't able to handle that with the address bus width, then it's not going to work. However, generally, the larger the RAM, the more efficient a computer will run. Not as much memory means that data is moved between secondary storage and RAM more frequently. So why not just use secondary storage? Remember, secondary storage is much larger than RAM, so why wouldn't we just use secondary storage? This is because of its distance from the CPU. It's a significant way away from the motherboard and the CPU, whereas RAM is built directly onto the CPU. So it's close, which means easy access and quick speeds. Here's an abstracted view of RAM. You can see at the moment I have my operating system in RAM. I also have a video editing, graphics app and word processing app. Notice how these applications are all actually stored on our hard drive and they're moved across to RAM when we want to use them. So when a program is running, we move that data back between main memory and the processor. Once it's finished running, the space in our RAM or main memory is probably going to be used for another program and their data. So anything saved will be written to the hard drive. Because of the way RAM is designed, it can be accessed, written and read at very high speeds. If you look under a microscope, you'll actually see that RAM is made of hundreds and thousands of tiny transistors. Each of these transistors holds a charge, and that can then be represented as a 0 and 1. On the left of the screen, you can see a transistor. Now, RAM is built of memory cells, and as we said already, a single cell can store either a 0 or a 1. So these are then stored in a memory location, such as a transistor. We might store 8 of these together. Therefore, RAM has lots of memory locations, which are used to store data. This data could be instructions, or it could be bit patterns. RAM is addressable, and what I mean by that is every location in RAM has a different, unique address. Imagine when you're walking down the street. If all the houses had the same number, then post would never arrive at the correct address. So every location in RAM needs a different address. This is so we can retrieve data when needed. If a main memory has 64 memory locations, then the address of these locations will be 0 to 63, because remember, we always start at 0 when we're thinking about memory locations. Now in RAM, different memory locations are not necessarily sequential. We don't have to access them one after the other, because they all have a different address. Each location will take the same amount of time to access. This is why we call it random access memory. When we talk about loading memory, where are we actually loading it to then? Hopefully you've got the answer: the CPU registers. How many of the registers can you still remember? Try and write them down. You have two types of RAM inside your computer: static RAM and dynamic RAM, SRAM and DRAM. You're likely to actually have both types in each PC, but it comes down a lot to cost as why you might use one over the other. Let's first have a look at DRAM. Now you can think of RAM as having hundreds of thousands of these tiny miniature capacitors and transistors. In DRAM, each memory cell holds one bit of information, and that is a 0 or 1. Inside the capacitor, you can think of this like a bucket. It can hold an electron. The transistor then acts as a switch, which lets us change the state of the capacitor. It might change from a 0 to a 1, so it might hold a charge or it might not hold a charge. It's dynamic because, unfortunately, the electrons will leak out over time. So we need to continue to keep flashing our RAM with the same data if we want to store it, to ensure that it doesn't lose that information. That is because it's volatile. SRAM stands for static RAM, and these use a form of flip-flop to hold memory. You can think of this a bit like Boolean logic. That means each cell takes 4 or 6 transistors, along with a series of wiring, but this never has to be refreshed. So this makes it significantly faster than dynamic RAM. But there are more parts, it's going to take more space on the chip, and therefore you get less memory per chip. And that actually makes it a lot more expensive. The second type of primary storage is ROM, read-only memory. Remember, we talked about CD-ROMs already, things that we can read from but we can't write to. ROM is also located on the motherboard. It's a small amount of non-volatile memory. That means that it doesn't lose its memory when we turn the computer off and when it loses power. We use ROM to store the boot sequence, or the BIOS, for a computer, and BIOS stands for Basic Input-Output System. The first two things that it will do is check the core components of the computer system are connected and responding correctly. So these components include RAM, our input and output devices, and our secondary storage connected devices. You've probably seen, when you turn the computer on, a black or blue screen with a series of instructions which are loading in the background as it loads and checks the system. The second part is it's going to load the essential parts of the operating system. Remember, the operating system is secured and saved in the secondary storage or on our hard drive. So it needs to load parts of this into RAM. It only loads parts so that the operating system can start to load. Once this has been done, it's actually the operating system that will then take control of the management of the computer system. We'll look at this in the next unit of work. Think of it like this. When you wake up in the morning, you might not know what's going on or what time it is, and you'd need to find out some information. So when we wake up, the first thing that's given power is ROM. The ROM lets the CPU know that it's been turned on, because the CPU doesn't even know the hard drive exists at the moment, because the ROM holds the BIOS, and that is loaded directly into the CPU, and it's the first thing that happens whenever we turn the computer on. Once this has happened, the CPU will then load the operating system from the hard drive into RAM. Remember, that's only the parts that we need. Your next task is to match up the different statements into the correct categories. You'll need to use the following page to complete that task. Here are the answers. Check the answers that you've got and make sure you've got all your correct answers. You've been given a series of exam questions. Some of them are an easy challenge, or some of them are hard. Have a look at the questions and consider what is being asked of each of the questions first before we answer them. Then mark your questions and make improvements.